Woohoo! We are live. This is Math 40, elementary algebra, and we are still solving equations. I've got a bunch of highlighters, handy dandy highlighters. I've got my work, I've got my reminder, adding and subtracting first, then multiplying, divide to keep balance. Let's get started. Now, I promised you last time that these would be slightly more interesting, maybe more difficult, certainly more complex. So, woohoo! You might want to have a couple of support animals around. I've got my support Godzilla, of course. Just a mom trying to take care of her kids. And, a little support vampire. Could happen. Okay, shall we do it? I'm surrounded by good, happy feelings. I've got my wonderful water. You always want to hydrate. Make sure you're hydrating. Let's do it. Solve some equations. Okay, so first problem, solve and check. And it starts off, pardon me, in a very complex way. I'm going to have to simplify each side. So let's go ahead and do that. Simplify each side. So I've got 9 times the quantity t plus 2 equals -6 times the quantity t minus 3 plus 15t. Oh my goodness, lots of t's running around. So first thing is I'm going to go ahead and use the distributive property to multiply out. So I get 9 times t plus, there's the plus in the middle, and then 9 times 2 is 18. The left side's not too much. The right side's got a lot of stuff going on, so I'm going to go slowly and carefully. -6 gets multiplied through. So because of the minus sign in front of the 6, I am going to make sure I change the signs, right? -6 will change the signs. So -6 times t is -6t. So the t went from being positive to negative. And now here, notice it's -6 right there times -3. And where are my Bat Brothers? I need the Bat Brothers. Here they come. Oh, one of the wings got broken. Okay, here we go. 2 minuses, make a plus. 2 minuses, make a plus. Woohoo. Okay, support bats. Here we got some support bats. It's good to be surrounded by friends when you're doing hard math problems. -6 times -3 makes a positive 18. And then we have that plus 15t. Notice that the 15t is not in the parentheses, so the -6 doesn't talk to the 15. It's okay. It's nothing personal. It's just they're not in the same place. Okay, so I'm going to take a look here. I'm going to use yellow for my variables. I've got a variable here, just a single one on the left. That's awesome. However, I have 2 variables on the right. And generally speaking, what you want to do with these 2 terms that have variables in it is you want to combine. So I've got the -6t, and then I'm going to use the transit. I'm going to come up with the name of it if it kills us. I'm going to use the commutative property to swap the order of these 2, right? So then it becomes plus 15t plus 18. And then I can combine these in the next step. 9t plus 18 equals 9t plus, and then I go, oh my goodness, wait a minute. So here's what I'm going to recommend. Sometimes math is going to look weird. Your brain is going to say, oh no, I see something weird, run away. And the answer is you just have to calm your brain. You have to say, thank you, brain. Your brain is trying to save you from a saber-toothed tiger. It's okay. Math will not eat you like a saber-toothed tiger, believe it or not. So what we're going to do is we're going to just try some stuff. That's all you need to do. We are going to notice, oh, isn't that interesting? 9t plus 18, 9t plus 18. Huh, interesting. I am still going to try to combine the t's. Now, what does that mean? Well, remember that to move terms from one side to the other, I'm going to add or subtract. So I'm going to go ahead and subtract this 9t from both sides. Don't let your brain panic. I know your brain is trying to be helpful, but don't let it panic. No panicking. Okay, 19 minus 19, the t's cancel, and all I have left is 18. Over here, 19 minus 19, t's cancel. What do I have left? 18. This is true. This is true always. When does 18 equal 18? It always equals 18. Notice there's no t in here. So this is not a conditional statement. This is true always. So this means that any number you put in for t will work. It's kind of cool. In fact, what it means is this wasn't even a story about t. This was a completely different story. T has nothing to do with it. So you could plug in t equals 1. You could plug in t equals 2. You could plug in t equals negative 483,000. And so how do we answer this? Because I can't list all the values. And the answer is, you say this is true for all real numbers. You could say, some people will just say the figure for r, or you could say t is an element of r, or you could say the interval from negative infinity to infinity. So these are all ways of describing the same thing. Basically, it is true no matter what you put in it. And there's a note down here. These types of equations are called identities. If it is true, like what you might call a tautology, in math we call it an identity. So an identity means it is true regardless of what t is. Now, in algebra to come, if you continue on with algebra, the next step for the checking, we would pick a couple different t's to check. And in fact, it's not a terrible idea. So let's go ahead and try it. I'm not going to require it of you. It's enough to get to this point and say, this is an interesting problem. But why don't we try? So for number 1, let's try a check. It's going to be a little bit harder because I'm going to have a hard time hearing you through my computer monitor, but I'm willing to give it a try. So I'm going to pick any two, oops, sorry about that. Where's my handy dandy mistake correcting tape? Any two numbers. Any of them. I'm going to pick 0 because I think 0 is one of the easier ones to use. So I'm going to try t equals 0. So I get 9 times the quantity 0 plus 2. And is that equal to negative 6 times 0 minus 3 plus 15 times 0? Okay, over on the left, that's 9 times 2, which is 18. Woohoo! Okay, over on the right, this is a lot more complicated. I get, let's see, negative 6 times 0 minus 3, negative 3, plus 15 times 0, that's 0. Negative 6 times negative 3 is 18, plus 0 is 18. Did it work? Woo! So it worked for t equals 0. Maybe I just got lucky and I randomly picked the correct number. Let me try another one. I'm going to pick t equals 3. I'll show you why as we work through it. Sometimes you can pick smart numbers. That'll just make your life a little easier. So I'm going to have 9 times the quantity 3 plus 2 equals negative 6 times the quantity 3 minus 3 plus 15 times 3. Okay, over here, this is 9 times 5, which is, I happen to know from my times tables, 45. Over here on the right-hand side, I've got negative 6 times 3 minus 3, 0, plus 15 times 3. So this is going to be 0. That's why I picked 3. And then plus 15 times 3. What's 15 times 3? Well, 2 times 15 is 30. So 3 times 15 is 45. Woohoo! Look at that. 45. So if you pick any two numbers and both of them work, and it's a linear equation, you can be sure that all the numbers work. It's just kind of it seems magical, it's not really magical, but it turns out it's not something I can explain very well in this class. So if you continue on with Math 60, we'll talk about it a little more, and then with Math 90, it's so on and so forth. So you just take it for granted that this is true. Now, are you required to do that? No. In this class, you guys should get to here. You should know the word identity. You don't have to do this. I just wanted to show you any two numbers I picked would work, and I guarantee any number you pick will also work. It's kind of cool. Okay, so that's the first one. Now, what other interesting things are happening? Well, this is another interesting one. Shall we get started? Yes, let's get started. Okay. So I've got the equation 5 times the quantity x plus 3 minus 3x, and I want that to be equal to 2 times the quantity x plus 8. Okay, so I'm going to use the distributive property. I get 5x plus 5 times 3 is, you got it, 15, minus 3x. Over here, I'm going to use the distributive property. 2x plus 2 times 8 is, you got it, 16. Let me look for my variables. I got a variable term there, a term with variables there, and a variable term there. Okay. I got two of these guys on a single side, right? If we put the pen down where the equal sign is, we can see, okay, these are on both the left side. So I'm going to use the commutative property to change the order. And then the right side is just going to hang out. It's got nothing to do right now. It's all simplified. But I'm going to go ahead and combine these two. 5x minus 3x is, you got it, 2x. And now my brain is already yelling at me. My brain's like, oh my goodness, do you see that? Oh my goodness, this is the end of the world. Why do they match? Oh my goodness. And the answer is, it's okay. Everything is fine. I mean, if things get really bad, if the math gets really scary, you just turn the paper over and that's it. You've defeated the math. Math can't hurt you. So, but I don't think the math can hurt me. I just want to take a good look. I got 2x plus 15 has to be equal to 2x plus 16. That doesn't seem likely. But with the x's in the equation, I'm not sure. So what I'm going to do is I'm going to go ahead and I'm going to say, okay, I'm going to move the two x's. So I'm going to subtract 2x from both sides. Okay. What happens? These x's cancel. These x's cancel. On the left, I've got 15. On the right, I've got 16. Does 15 equal 16? And the answer is no. Can you go into the bank and the bank says, well, you have $15? Can you say, or do I have $16? No, you can't do that. Well, you could try, but then the bank will ask you to leave. So these two things are not true. See, I put the line through, it means not equal. This is false. And that means there's no solution, which is sad. In other words, we have set up a situation. For example, I have said, I would like to find a way to have a pet rabbit that flies. And the answer is, no matter how long that rabbit spent in flight school, I can't get it to pass. I mean, rabbits are just rubbish when it comes to the instrument test. So that rabbit will not fly. It's just not possible. So we say no solution. When we mean this equation is not possible, there's no answer that satisfies. So no number of all the numbers, not a single one will make this true. No solution. If that's the case, we call it, and this is not too far from what we call it in regular English too, a contradiction. In other words, contra means to against, and diction means to speak. So you're speaking against, you're smashing together. You're like, I want to go this way and that way, and you can't. So there we go. Two different kinds of strange problems. What is you know, because these are pretty weird. So what's the takeaway for both of these? If I can kind of connect the dots between them. And the dots are that if you get it to a state where you've got the same term on both sides, 90 and 90 or 2x and 2x, move that term by subtracting, get down to where you've just got numbers and compare the numbers. If the numbers match, it's always true. If the numbers don't match, it's basically always false. There's no solution. So this is all the solutions. This is none of the solutions. Woohoo! Awesome. Okay, next up, this one's going to be, I would really encourage you, get some water, get a support animal, get a snuggly blanket, you know, basically get some fun stickers or whatever it is that you do that makes you feel good. And we're going to get started on some somewhat more difficult equations, but we're totally going to do it together. Woohoo! Okay, you guys ready? Math on, you guys, math on.